Hello friends, can I ask you a question? How many sensing organs does our body have? Oh, it's a baby question. I know that. Even a small baby can answer this. But we all know that we have 5 sensing organs in our body. Nose, your tongue, your ears, your eyes and your skin. Okay, these 5 sensing organs connect our brain to the external environment some way or the other, right? But why are we discussing about human sensing organs? Because we don't deal with biology. But there is a reason. The sensors that are surrounding us are the replica of the human sensing organs. Okay, they exactly do the same function to the devices, to the appliances, to the robots, you can say, as they do to our body. Okay, so I'll just make it very clear. Okay, so the sensing organs that we have in our body are exactly similar to the sensors that are present in any robot, any device or any appliance. Okay, so they are just replica. Okay, so those are biological things and the sensors are completely electronic things. Okay, we all are actually surrounded by sensors, isn't it? So in our daily life, in our day-to-day life, we are using a lot of things, a lot of devices, a lot of appliances, a lot of objects which are equipped with sensors. Am I right? So when we talk about sensors, there are a lot of sensors that come to our mind. So here I'll be covering almost all the sensors that we are going to use. Okay, for example, we will be looking into ultrasonic sensor, infrared sensor, proximity sensor, then accelerometer, gyroscope, then temperature sensor, smoke sensor, and some other sensors as well. Alright, so we will be learning about the structure of those sensors, and we will also learn how these sensors work. We will look into the working principle of those sensors, and the most importantly, we will learn how to use those sensors. Okay, so we will be designing circuits with those sensors, we will be designing robots with those sensors, and I will train you how we can program those sensors using some microcontroller. So basically we will be combining those sensors with Arduino, and we will design some projects in our upcoming videos. Okay, so today we will start with one very beautiful and basic sensor, that is ultrasonic sensor. All right, so this is how the sensor looks like. Okay, this is called ultrasonic sensor. Right, so if you see properly, it looks like 2 eyes, right? And it works like the eye of any robot or any device. Okay, I'll give you an example. Okay, you all have seen the reverse parking sensors in the cars. Okay, whenever you are taking your car in reverse, there are sensors at the back, okay, which help you in avoiding some collision. Okay, so that you do not hit something, and the sensors give you signals. Okay, it communicates. So this is something which is very important, and we can actually design a lot of useful devices with this. Okay, so its name is ultrasonic sensor, so from its name only you can have some idea how it works, right? So this sensor basically works on the principle of ultrasound. Okay, so for those who do not know what is ultrasound, let me tell you that ultrasound is a type of sound whose frequency is more than 20,000 hertz. Okay, that means 20 kilohertz. So basically ultrasound cannot be heard. Actually, it's not audible to human ears. Okay, only some animals can hear it. Okay, so actually the frequency of sound is measured in hertz. Okay, so the sound whose frequency is more than 20,000 hertz is called ultrasound. Okay, So this device has two structures, as you can see. One is transmitter, one is receiver. So this transmitter transmits the ultrasound, okay, it goes, strikes the object, comes back as an echo, okay, it's received by the receiver, and the received echo is converted into electrical signal, and this circuit sensor has a system, an algorithm, okay, with the help of which it can find out that there is some obstacle in front of it. Obviously, if the echo is there, that means what? The sound, the ultrasound is coming back after hitting something, so it obviously comes to know that there is some obstacle present, and it also comes to know that the distance, okay, how far the object is situated at, okay. So this is how this sensor works, okay. Now one important thing about ultrasound is the speed of ultrasound is actually similar to that of normal sound, because it's also sound, okay. So it's somewhere around 343 to 347 meter per second, which is approximately taken as 350 meter per second for mathematical calculations, okay. So that is the speed of ultrasound, right? So this receiver, so like this complete module makes a calculation, okay, from the time of transmission of the ultrasound to the time of reception. So it counts the time, so it comes to know how much time the signal takes to come back. So that is the time, and we have the value of the speed. So using that thing, it can calculate how far the object is situated, okay. So now it's time for some design, okay. I have made a very basic prototype, okay, a prototype which is actually similar to a reverse parking sensor prototype, okay. I'll be just showing you. I have incorporated this entire things with Arduino, okay. So this is the Arduino, okay. There's a basic circuit, okay. So this is the sensor I'm going to put. It was already there, I just removed it. So okay, so I have put the sensor here, okay. Now there are three LEDs. I'll talk about these LEDs later on, okay. A buzzer, and I have connected everything to Arduino, okay. Now let me tell you one thing. I'll give you a closer view of the sensor, okay. So have a closer look, okay. This sensor has mainly 4 pins, okay. One is trigger, one is echo, one is VCC, one is ground. So trigger pin is responsible for sending the ultrasound, okay. Echo pin is responsible for receiving the ultrasound, which is coming back after striking the object. VCC means the plus, and GND means the minus. So every device needs 2 terminals, positive and negative. Those are those 2 terminals. All right, now I've connected it like this. All right, so this circuit might look a little bit bulky, but it's not. It's a very basic one, okay. So we have connected 3 LEDs, okay, one green, blue and red, okay. So how it works is, when my hand is here, okay, around 50 centimeter, okay, then what happens is my sensor comes to know that the object is at a safe distance, and in that case the green LED will glow, okay, and the buzzer will make some sound which is mild, okay, not sharp. If I move my hand closer, then the sensor comes to know that the object is approaching. So in that case, it increases the intensity of the buzzer, okay, and parallelly it glows the second LED, that is blue LED. All right, now if I move my hand extremely close to the sensor, then the buzzer again changes its intensity of the sound and the red LED glows. So this is how the reverse parking sensor in a car also works, okay. So I designed this basic project just to make you understand how ultrasonic sensor works, okay. Now I'll show you a closer look of this circuit as well, all right. And Now without the program it doesn't work, okay, because I have connected the entire circuit to a microcontroller board, that is Arduino Uno. Okay, so what we do is we program this entire circuit, okay, and I'll upload this code and this is going to run. Okay, so I'll just show you the code. Okay, just have a look on the code. So guys, this is the program. Okay, this is the Arduino program that's going to make the entire project work. Okay, so I'll be providing this entire program in my official Facebook page. Okay, if someone needs this code or someone needs any kind of assistance regarding the code, you can get in touch with me through my Instagram or Facebook. Okay, so let's start with the program. So it's here I have first defined the trigger and echo pin of the ultrasonic sensor. Okay, so the first pin, that is trigger pin, is pin number 7 and echo pin is pin number 6. I have defined it here. All the 3 LEDs are defined as pin number 10, 9 and 8. Okay, so that means I am using all the digital input output pins, so that is 7, 6, 10, 9, 8. Okay, buzzer has been connected to pin number 3, and initially I have given some sound intensity here as 250. Okay, that is the value for sound intensity. Okay, so it is actually given as integer value, so int stands for integer. Okay, now inside the void setup I have to define each and every pin as an output or input pin. So trigger pin has been defined as output, as you can see. Echo pin has been defined as input. LED, all the LED pins are defined as output. Okay, and the buzzer also has been defined as output, right? So next I am talking about these 4 things. Okay, first I am making the trigger pin low. So trigger pin is responsible for sending out the ultrasonic sound. All right, then this is a delay. Okay, that means for 2 microsecond the signal will be low, that means it's 0, so that means it will not emit any kind of ultrasound. Again I'm making it high, that means trigger pin is high for 10 microseconds, so that means for 10 microseconds the ultrasonic sensor is going to transmit some ultrasound. Okay, then it's going to be again low. Okay, now it will, I told you that it will measure the time, so the duration is pulse in, echo pin, high. So now echo pin means the pin which receives the echo when the ultrasound comes back after striking the object. So until and unless this echo pin becomes high, it will not count the duration. That means from the time of sending the signal to the time of receiving the signal, that is the duration. And it actually uses one standard formula, that is this one. Okay, so in a detailed code I'll be explaining how we get this 29.1. it's a calculation. Okay, it's related to the speed of sound. Okay, 343 meter per second. Okay, by using that value we actually find out this 29.1. I'll tell you mathematically how we get it. Okay, so this formula is used to find out the distance. Right, now here is the main algorithm that we have written. Okay, we are using if else statement. Okay, if the distance is less than or equal to 50, then digital write LED for high. Okay, so it's going to turn on the first LED. Okay, and its sound will be 250. So 250 is a mild sound that will be made by the buzzer. Right, else, so if distance is less than or equal to 50 centimeter, it's going to glow the LED and it's going to make some sound, or else it's going to make the LED low. All right, and if the distance is less than 25 centimeter, it's going to make the LED 5 high. Okay, and the sound will be 290. That means this is going to glow the blue LED and the sound intensity also increases. Else low. Okay, if and else. Okay, if this, then do this, if no, then do this. Okay, it's very simple. Now the third condition, as you can see, when it's in the extreme closest position to the ultrasonic sensor, the third LED, the red LED glows and the sound intensity has gone to 370. Okay, it will make a very sharp sound and the red LED will also glow, or else it's off. Okay, now if the distance is greater than 30 centimeter, okay, or distance is less than or equal to 0, okay, this function is actually made for a one okay, I'm just okay. So now this part is for printing the distance, okay, for measuring the distance. Okay, for this we will be using either the serial monitor of the Arduino program, that is this. Okay, if we click here we get the serial monitor, but we have to connect one Arduino board to this computer. Okay, then it will open up one monitor. Okay, that's the digital serial monitor where we can actually get the distance of the object as well. Okay, now we have already connected the board to the computer. We will go to tools, select the serial communication port, that's COM port, COM3. Then we are going to compile by clicking on this button. Okay, the first top left corner button is for compiling. I'm clicking it here, so it will start compiling the code. Okay, as you can see. Okay, so it's showing done compiling. Right now I'm going to upload this by clicking on the next button here, this one. So let's see, it's uploading. So as you can see, it's showing uploading, and here it's showing done uploading. Right, so the code has been uploaded to the board. Okay, so our circuit is ready. Okay, we have done the programming here as I have already shown you. Okay, now we are going to test it. Okay, so this is the distance the sensor actually cannot detect. I have made the minimum distance, minimum 30 centimeters. So if it is approaching, it's approaching this 30 centimeter, it detects. As you can see, the green light is glowing and it's detecting my hand. Okay, and it's actually, so as you can see the difference in the sound that the buzzer is making. So this is 30 centimeter. Now if I go further, so this is how the sound makes in different kind of, yes, as you can see there are difference in sounds. Okay, so if I'm approaching closer to the sensor, the sound intensity of the buzzer actually increases. Right, as I've already shown you in the program how we do it. Right, now if I move extremely close to the sensor, as you can see the red LED is glowing and it's making a very sharp sound. Okay, so this is how it works. Okay, so first of all, the object should be in the line of sight. Line of sight means it should be in the line of sight of the sensor. Okay, it will not detect the entire range. Okay, so it has a specific area where you have to put the hand. Okay, then only it will detect. Right, so this is how this model works. Okay, in the upcoming videos, in the upcoming days, I'll be designing some more devices with this sensor. Okay, and the most important use of this sensor is obstacle avoiding robot, okay, which we'll be designing very soon. Okay, I'll be telling you, I'll be training you, I'll be demonstrating how we can design an obstacle avoiding robot using this ultrasonic sensor, right? So I hope you have liked my video. Okay, I hope this content was beneficial for you. Those who have not yet subscribed to my channel, please subscribe, and don't forget to hit the like button. All right, till then, bye bye, thank you for watching. Oh, okay, I forgot to announce one more thing, right? That is, this video is also coming in Assamese. Okay, so I have already started making my videos in both the languages, English and Assamese. So I'm going to make this video again in Assamese. Same video, this video is going to come in Assamese, okay, complete Homia. So please stay tuned, okay, for more videos. Till then, bye bye, thank you for watching, keep learning.